Hey gang, so today is math day in Science 9. So as you can see, I have my cheat sheet, I have my calculator, and I have brought on a copy of 10.2 to start things off. So let us begin by doing one further alteration on this equation here. And I'm going to pull it in so we can make the appropriate notations. And so we said that Q is charge. And this is measured in coulombs. We said that T is time in seconds. One small s, that's what we do for seconds. And I, of course, is current. And current is measured in amps. So we have that there. The one thing that we want to do is we want to talk about a coulomb, or at least we want to talk about the relationship between the number of electrons and a coulomb. So this is what you need to write down. You need to write down 1 coulomb, 1 capital C, is equal to 6.25 times 10 to the 18 electrons. So we have this on our page, so we won't lose this, right? Okay, let's put that aside for a minute, and let's look at the questions on the bottom of page 8 of our note package. And this is referring to CYU 10.2 on page 309. And basically what it's asking you to do, it's asking you to take this diagram here and put one, in the first instance, put another lamp in series with this lamp here. That's the first question. The second one is to put one in parallel. So series, I'm just going to redo it, do it like here. So right now it looks something like this. At the top we have the switch, and we have, now I'm just going to go down like this far like this. And I'm going to put the first, so this is the first one, okay? In series means that it's one after the other, like so. So this is what they're looking for in series. In parallel, what they're looking for is, here's the cell, here's the switch, here's the first lamp, so the second lamp I'm going to put right here. I'm not good at these little diagrams, these little lamps, like that. So that's it. That's all they're asking for. One in series, one in parallel. Okay? Page over. Figure 9 is saying that is looking at this guy here. Whoopsie daisy. It says you've got 5 ammeters. So you got 1, 2, 3, 4, 5. And which ammeter or ammeters is going to measure the current in this light bulb as it goes through here? Now, remember that this is the negative end. Two things you need to remember. This is the negative end. So this is where electrons go. So electrons are going to go that way. And these lines reflect wires. And the other thing we need to remember is that all ammeters, in order to measure current, the current has to go through the ammeter. In other words, the ammeter has to be part of the circuit. So in this case here, this is not part of the circuit. Okay? The circuit is starting from here, going all the way around and back here. It does go here too, but in this case here, it's asking about the current that goes through the light. So in fact, there's only two of these ammeters that will measure the current going through the light. And that's this one here, because if you continue to follow the pathway of the electron, it's going to go this way, it goes through, so that's one, comes through the light, comes back down through the ammeter, back to the positive end. Okay? That's not too bad. Okay, I'm only going to do two of these next ones here, because we actually tried this the other day. And we said, okay, if we're wanting to move from milliamps to amps, we move to the left, 3 spaces that way. If we want to move from amps to milliamps, we move 3 spaces this way. What do I mean by spaces? I mean 3 decimal points. So 489 milliamps goes, because the decimal point is starting out through the 9, so it goes 1, 2, 3, and that's where the decimal goes. So this is 0.489. Okay? If we want to move from amps to milliamps, we do 3 in the opposite direction, 3 to the right. So this goes 1, 2, 3. So 0.055 amps is 55, oops, do this color, 55 milliamps. So you can do the rest of that, okay? Question 10 is asking about this one here, this figure here. We'll go in, here we go, here we go, here we go, get close, get close, get close, get close. Okay, so what you want to look at is that this goes from 0 to 1, and so this is 0.2, 0.4, 0.6, 0.8 amps. So this is pointing at 0.2 amps. And so really, this question here, I'd have felt better if they put the amps first, because this is 0.2 amps. And now we have to use our rule about going from amps to milliamps, and that is we're going to move this 3 to the right. So 1, 2, 3, so 0 goes there, 0 goes there, so this is going to be 200 milliamps. Okay? Okay, this is when our calculator is going to come in easy, or handy. And this is what I like to do. I'd like to do one. I want to do this one here. I'll walk you through this, and then I'm going to get you to do this. Then I'm going to do this one as an example, and then I'll get you to go back 1 space and do this. Okay, so I'm going to do 1 and 4, and so you're going to do 2 and 3. So let's do number 1 first. And so again, what we want to do is we want to circle what we're looking for and what we're given, and label them. So it says determine the current. Determine the current means I want to find I. I is what I'm looking for. 13 coulombs. Coulombs is charge. So this is 13, this is the Q, of electricity passes through in 26 seconds. So this is T. So I'm looking for current, and I'm given coulombs and time. So current, so this is what I do now. I write down the equation that I need. Current is equal to coulombs divided by time, and so this is equal to 13 coulombs divided by 26 seconds, and I can do that one in my head. That is 0.5 watt. If you said amps, you were absolutely right, because current is measured in amps. Okay, so now what I want you to do this one, and pause the button, and then do the work, and then come back, and I'm going to do it myself. Okay. Okay, I take it that you're back. So this I actually made a mistake over here. I didn't change this to milliamps. So this one here, time is 10 minutes. Now this will only work if you change time to seconds. Otherwise, it's not going to work. So that's my first thing. Just 10 minutes is equal to 60 times 10, or 600 seconds. Current is coulombs divided by seconds, comes out to 1.67. They wanted it in milliamps though, so that means I have to move this over 3. 1, 2, 3, 167. So my mistake over here is I didn't do this last step of moving the decimal. It wants it in milliamps, so 0.5, 1, 2, 3. So this is going to be equal to 500 milliamps. Okay, now this figure here, this piece of information that we just put in our card, this is going to become important in both of these, both 4 and 3. So let's see how we attack this. If the potential failed current is 1 amp, so 1 amp, that's current. That's current. Determine if 7.4 times 10 to the 19th electrons passing through a circuit in 10 seconds could kill someone. Now, how are we going to find out if it could kill someone? We're going to go back in our notes, because I don't know if you recall from, I think it was the day before yesterday. No, was it yesterday? We said how many amps would kill, okay? Because we use the word lethal. Okay, so this is the number of electrons. This is number of electrons, and so we're going to use this to determine the number of coulombs, and then 10 seconds here's time. Okay, so step number 1, we're going to change the electrons to coulombs. So how you do that is you take this number of electrons, 7.4 times 10 to the 19 electrons. You can divide it by 6.25 times 10 to the 18 electrons per coulomb. And that's going to give us, out comes the trusty. Now, on mine, I'll show you how I do this on mine. And then if yours may say EXP. If it's a Texas Instrument, it'll say EE. And some others will have 10 to the X power. But I'll show you how to do this one. So, I got to see what I'm doing here. So, 7.4 exponential 18. Okay, so this value here is another way of writing, oh, not 18, that's 19. 19, okay? So this here is another way of writing 7.4 times 10 to the 19, because times 10 is E. Okay, so now I'm going to divide that by 6.25 exponential 18, and that's going to be equal 11.84. So this is 11.84 coulombs. So that's the charge. Oh, I'm sorry. Fatal current is they give us is 1 amp. So now what we need to find out is, do these two things together give me 1 amp? So part 2. Current is equal to charge divided by time. So 11.84 coulombs divided by 10 seconds is equal to 1.184 coulombs. So the answer is yes. This will kill you because this 1.184 coulombs is bigger than, oh, no, I'm sorry, not coulombs, that's amps. What are you thinking, Hayden? Jeez. Okay, so yes, okay. Now, what I want you to do is I want you to do this one here, okay? Okay, so stop the video and then come back, okay? And I'll solve it while you're away, and so you can see it when you get back. Okay, there you go. Off you go. Okay, so I've taken you back. So this is pretty much the same thing that we did over here. First step was to change electrons to coulombs, so we divided the electrons given by this number here, and that came out to 1512 coulombs. 1512 coulombs divided by the time, or 108 seconds, is equal to exactly 14 amps. So good job! Yes! Yes! Okay, let's move along. So you're tracking along, moving along nicely. And so let's see what we have here. Okay. Now, every one of these is going to use this relationship here. I is equal to Q over T. And you're going to be given two of these items and solve for the third. Now, in this, you could be given I and T, solve for Q. You'd be given T and Q, solve for I. Or you could be given I and Q, solve for T. It's all the relationships, okay? So what I want you to do is I want you to do these four right now, and I am going to do them myself, and then we will come back and do the deal, okay? So stop now. I'm anticipating this is probably going to take you maybe 3 minutes for each one of these things. So maybe gave you 15 minutes. So come back if you get stuck. Just give it your best shot, and then come back and see how I do it. Okay? Okay. See you in a bit. Bye now. So that's that one, 12.2 minutes. You can pause here and then come back to. I'll still be here. go over 3, 1, 3, so this is 0.35 amps. You always have to change to amps. Okay. Charge is equal to 185 coulombs. And look for time. Time is equal to Q over I, which is 185 divided by, ooh, this is going to be a big number. Big number. 185 divided by 0.35 is equal to 528.57. Let's call that 529 because it's closer to that. And this is what time? This is in seconds. So in minutes, I'm going to take 529 seconds divided by 60 seconds per minute. And that's going to be divided by 60, divided by 60, 8.8 minutes. Okay? You can pause it now and if you like and then come back. Okay, you've been rubbing your sock on carpet for the last 10 minutes to build up a static electric charge. The actual shock is 50 milliamps and produces a charge. How long did it take for the shock to jump from your finger to your victim? So the current is the movement of electrons. So we can use Q equal IT, or I is Q divided by T. So let's see what we've got here. We have got, that's our charge. It's Q. Here is I, and they're looking for T. How long did it take? So the first step is I have to change I'm sorry, you can't see that. You have to change milliamps to amps. So first step, 50 milliamps. So I need to move this 3 that way. So it's 1, 2, 3. So it is equal to 0.050 amps. And T is equal to Q divided by I. Q is equal to 0.001 coulombs divided by 0.050 amps. So 0.001 divided by 0.050 is equal to 0.02 seconds. So 2/100ths of a second. Not so bad. A current of 120 milliamps. So this is the current. Goes past the point in 25 seconds. Oh, that was easy. Time. How much charge passes the point in this time? Oh, okay. So first things first. For A, first things first, I need to change milliamps to amps. So that's going to be, I have to go this way. So 1, 2, 3. So 0.120 amps is current. And time 25 seconds. So charge Q is equal to I times T. I is 0.120 amps times 25 seconds. What does that look like? 0.120 times 25. Ooh, that's a nice round number. 3 coulombs. There we go. And doodle. Okay, I'll doodle. There you go. That is actually my signature. Oh, true statement. I'm not lying to you. You ask any of my Japanese students when I was overseas in Yokohama, they'll tell you that's Mr. Hayden's signature. True, true. Okay? I don't even know what that says. Jeff Frog has a shocking personality. Oh, I get it. Hooking his tongue to an ammeter shows 100 amps. Whoa, dude. That's huge. 100 amps. That's current, man. Of current. Determine the charge produced in coulombs and electrons. But should you be unfortunate to get a 25-second tongue lashing? Oh man, you can tell that this was made by Mr. Dory. So this is the time. And so, charge, so A in coulombs, Q is equal to I T, or I times T, which is I is 100 amps times 25 seconds. 2,500, right? I'm just going to write through my calculator. I'm that way times 25. Yeah. So, which is equal to 2,500 coulombs. So you're asked to translate this to be a in electrons. So in 1 coulomb, you have 6.25 times 10 to the 18th. That's what it says here. In 1 coulomb, you have 6.25 times 10 to the 18th. So how many if you've got, how many? 2,500. Ooh, this is going to be a big number. Oh, dude. So you're going to say 2,500 coulombs times 6.25 times 10 to the 18 electrons per coulomb. Whoa. Times 6.25 exponential 18. Whoa, that's a big number. 1.56 times 10 to the 22nd. So 1.56 is 22 zeros behind it. Yeah, yeah. Okay. So, down below, you have all of the answers to those questions. So now you can go back and make sure that we did it right. Okay? So you do that. And we're going to call it a day. So you've got 25 minutes, so you can use this time to catch up on other stuff. Or, yeah. I hope you feel more comfortable with our with what we did here. And my suggestion, for fun, this is just for fun, is that on page 309, I'm not going to collect this, and you don't send me any pictures, but there are some questions on 39, like 12 and 13, 12, 13, 15, or maybe the last four. Those would be good for you just to practice. You've got 24 minutes now, so be a good idea. You'll probably need to be able to do this for the chapter test, so try those out. And if you get stuck, please get a hold of me in my office time, and we'll work through them together, okay? Love you. Go away.